should be to this page. This page you can cross off, and also this page you can cross off. Those are things that you aren't going to be touched on. And actually, I don't really even know why that is in there because I haven't taught it for a couple years. Because really, those special product patterns you can find just by multiplying the way that we did before, so I'm not even going to worry about it. Alright, so factoring and solving polynomial equations. There are not many patterns that I'm going to make you memorize, but you have to know these following three. This one should look familiar because it's one that we've actually talked about before. Sum of two cubes, difference of two cubes. The reason that you have to memorize these two, well, all three, but these two specifically, is that to factor cubic functions that look like either a sum of two cubes or a difference of two cubes, this is the only way to do it. So you do have to know the pattern for those types of problems. Little pre-work here. For this section, factoring, that's going to look really similar to some of the factoring that we did with quadratics way back when. And solving, same thing. When we solved quadratic equations, our answers represented the x-intercepts. That's going to be the same for this. We're just extending what we did with quadratics to include cubics and quartics. So you're going to see a lot of connections. I'll probably use some even the same words or the same patterns because they are obviously connected. They're all polynomials, so factoring them is going to look very similar. Alright, for difference of squares, the general format that would have to be in would be a squared minus b squared. And then to factor that, the factored expression would be whatever the square root of a is, goes in both parentheses. Whatever the square root of b is, goes in both parentheses. The parentheses look exactly the same except one's positive and one's negative. An example of this would be 4x squared minus 9. You can take the square root of 4x squared. You can take the square root of 9. You're subtracting, so it fits the difference of two squares. So you're going to get 2x minus 3 times 2x plus 3. Okay. Sum of two cubes. Sum means adding. Now you'll see that the two terms are now cubed. To factor this, the pattern is a plus b times a squared minus ab plus b squared, where the a and the b are the cube root of both those terms. An example of this would be x cubed plus 8. You can take the cube root of x cubed, it's just x, because x times x times x gives you x cubed. You can take the cube root of 8, which is 2, because 2 times 2 times 2 is 8. So if it's going to fit that pattern, then the a would be the cube root of that, which is x. B would be 2, because it's the cube root of 8. So you'd have x plus 2. So if my a is x here, I'd have x squared. A times b would be 2x. And then b squared would be 4. So to factor this sum of two cubes, you would have to figure out what the cube root is of both of these and then fit it into the pattern. Difference of two cubes looks almost exactly the same, except these two signs do like a little flip-flop. So now you have a minus b and a squared plus ab plus b squared. So just these two make a switch. And how I keep it straight and which is which, if you have a sum, the first parenthesis will have a sum. If you have a minus, the first parenthesis will have a minus. And then the first sign in the second parenthesis will be just the opposite of whatever it is in the first. An example of this would be 8x cubed minus 1. You can take the cube root of that, it would be 2x. You can take the cube root of that, it would be 1. So it fits into the pattern of 2x minus 1. A squared would be 4x squared. Multiplying those two together would give you 2x. And then b squared is just 1. Now, this minus here, you can't think of it as a negative 1. You just have to think of it as a 1 because the pattern takes care of all the negatives and positives for you. So you don't have to include the sign there with your a and b values. Alright, so why? Why do we test this? Why is this part of the curriculum? Well, because some polynomial equations can only be factored by using these two patterns. That's something I already said. If you do not have a sum or difference of cubes, so if you have a polynomial, a cubic or a quartic, but it doesn't look like one of those, then you have some other options to factor, and you actually know how to do these options already. The first one's called factoring by grouping, which is if you have 4 terms, you group the first 2, group the last 2. And then the second is if it's in quadratic form. Now, the wording there is important. If it's in quadratic form, that means it's a trinomial. It looks like a quadratic. That doesn't mean it is a quadratic, but it looks like it might be similar looking at least. You can factor like we factored quadratics before. This is what we're going to spend time focusing on next week. Also, if we're asked to solve the polynomial equation by factoring, we still follow the same rules. Once you factor, you set each factor equal to 0, and then solve for x, just like we did. And this, I want to kind of add in this, when you solve, so like when you set each factor equal to 0 and solve for x, you're finding the x-intercepts. Okay, for example 1, we're going to do 2 examples together here, so make an A and a B. And all we're doing for the first one is we're going to factor. So this first one we're going to make 8x cubed plus 125. Okay, first of all, if you have a cubic and you're adding, or even if you have a cubic and you're subtracting, there's only 2 terms. You want these 2 patterns up here to trigger in your mind if you know you have to factor. Now this is how you determine if you really can factor using one of those patterns. You have to be able to take the cube root of both of those terms. The cube root of 8x cubed, we're going to label that A. The cube root of that is 2x. The cube root of 125 is 5. Now, if you don't know off the top of your head if something has a cube root or not, I'll show you how to do it on the calculator, or you can test it out. So if you have a calculator, and if you go to the math button, you'll see that the 4th option is a cube root. So you could say, okay, I don't know if 125 has a cube root. You can plug it in and say, yep, it does, and it's 5. So as long as you can take the cube root of both those terms, I list those cube roots as my A and my B. And then because I have a sum, I know I have to use the factoring pattern for a sum of 2 cubes, which is that second option up there in the box. So I just copy down the general pattern right there that I need to use. And I'm going to factor, basically, once you find your A and your B, is just plugging them in where they go in the pattern. So A plus B would give me 2x plus 5. A squared, well, that's squaring that first value. So you get 4x squared, because you have to square the 2 and square the x. A times B, remember I said don't worry about negatives and positives here, just the signs take care of themselves in the pattern. So A times B, should be minus 10x, and then B squared would be 5 squared, so 25. And since all I'm having you do for that part A is factor, that's where you would stop. That's fully factored. If we wanted to go further, you could try to factor that quadratic like you would a normal quadratic. So you'd multiply A and C together. 25 times 4 gives you 100. But there's actually not 2 numbers that multiply to get 100 and add to get negative 10. So that's unfactorable, and we'll see why for part B, but that's how you would leave your answer. Okay, for part B, actually I'm going to make that an x. Okay, at first glance, this might not look like it fits a pattern because, well, first of all, there's a fourth, not a third, and both of them have x's. But remember, the common thing that we usually do when we factor, the first step is to see if there's a greatest common factor. Well, in this case, there is. There's an x. So I'm going to plot an x and then see what happens. Okay, now it might look that I have a difference of 2 cubes. But to make sure, I'm going to see if I can take the cube root of both of these terms. So, oops, cube root of 64, okay, that does have a cube root of 4. And the cube root of x cubed is x. And let's see if 27, well, no, I know 27 has a cube root because 3 times 3 is 9, and 9 times 3 is 27. So I know that my b value is 3. Now, because this is a difference of 2 cubes. And remember, the greatest common factor, we just kind of leave it out there in front. I'm just focused on what's inside still. Difference of 2 cubes. That pattern I'm going to copy from my box above. And then I'm just going to plug these in where they go. But I'm going to change this problem to actually a solving problem. But in order to solve, we're going to factor. Okay, so I'm going to put in 4x minus 3. So put in 4x for A, 3 for B. A squared would be 4x squared, which would be 16x squared. A times b gives me 12x. B squared gives me 9. Now, usually when you factor to solve, once you actually get your two factors, you're going to take each one, set it equal to 0. In this case, if I add 3 and divide by 4, you get 3/4. So that's 1x intercept. Then you take 16x squared plus 12x plus 9 and set it equal to 0. Okay, so to solve quadratic, we have some options. You can complete the square. You can use the quadratic formula. I'm just going to go ahead and use the quadratic formula here. So we have negative 12 plus or minus b squared, which is 144, minus 4 times a times c, all over 2 times a. Then I'm going to go ahead and punch that out. And I get negative 432. Okay, now that negative means that there's actually 2 imaginary answers. So if I'm asking you how many x-intercepts there are, actually there's only one x-intercept, this one. It's the only one we could plot because the other 2 answers end up being imaginary. And just so that you know, whenever you go to solve using these 2 factoring patterns, the sum of 2 cubes and the difference of 2 cubes, if you were to solve, this quadratic always gives you imaginary answers. And you can never factor that one. I mean, that's just the way these functions work when you have a sum of 2 cubes and difference of 2 cubes. And that will come in handy later when we're actually graphing some of this, that we know that fact, that this always gives us imaginaries. Okay, we're going to be practicing that a lot, that you get comfortable with those patterns. But I do want to flip and just do example 2 with you really quickly. And we'll do just maybe one together, and then we'll pick up with B for our next homework video. Alright, for this one, we're going to look at quartic. So x to the 4th plus 7x cubed minus 8x minus 56. And all we're doing at this point is we're going to factor. Now, this is obviously not a sum of 2 cubes or a difference of 2 cubes. First of all, there's more than 2 terms. And we have an x to the 4th. So then you have some other options. And this is just a hint, if there's 4 terms, we've factored things with 4 terms before. And we factored them by grouping the first 2, grouping the last 2, and then pulling out the greatest common factor. So if we look at the first grouping here, the greatest common factor is x cubed. And in the second factor, or second grouping here, my greatest common factor is negative 8. parentheses end up being the same, so I can say, well, it's x cubed minus 8 times x plus 7. With polynomials, like before we could stop there because we were just dealing with a quadratic, so you'd end up getting two linear terms. With polynomials, though, often you'll end up having one factor that's still a cubic or a quadratic. You always have to look at that one and see, can I go further? Can I factor that down even more? And actually, in this case, we can, because you have x cubed minus 8. That's a difference of cubes. So I'm going to factor this one over here and then write my final answer underneath. And I know that x plus 7 is part of that final answer. X cubed minus 8, this is a difference of squares. So that factoring pattern from the first page is that pattern there. The a and the b are the cube root of both the terms. So a is going to be x, and b is going to be 2, because the cube root of x cubed is x, the cube root of 2 is, 8 is 2. And then we just fit them in where they go. So you have x minus 2 times x squared plus 2x plus 4. Okay, so now this is the factorization, complete factorization of that first parenthesis. So we're going to glue these two to that last one. And that is our final answer because that's completely factored every single piece. I would write a little note here. I know I already said it, but it might be good to include it in your notes. Always check to see if you can factor anything more. Oh, I'm sorry, I mislabeled that. That's not difference of squares, it's difference of cubes. And you could probably write cube instead of drawing a picture. Alright, so that's where we're going to leave off. Make sure that you have all these notes down, and then tomorrow we're really going to practice